So far, everything we've done has concerned use of the formal algebraic probability rules. Now, those rules are very useful. They're used in many probability problems, but there are some probability problems where you can't use those. We have to use some other techniques. We have to go back to the basic definition of probability. So here's the basic definition. Fundamental definition: probability is the number of successes over the total number of outcomes. Now, in some very simple scenarios, you can just make a list of the cases, and then you can count up, all right, this many successes, this many total outcomes, it must be this over this. Usually that's not going to be enough to get an answer in a probability question. That might be a way to get the probability of one piece of the question. Often that's not going to be enough to answer a whole question. It turns out that many times when we have to use this approach of counting the number of successes and the total number of outcomes, the numbers are actually too large for us to simply explicitly count, and we have to use counting techniques. Now remember, all those videos we had back in the module on counting techniques, the techniques that we use, there's the fundamental counting principle. So if the first choice happens in k ways, the second choice happens in n ways, the third choice happens in p ways, then the total number of ways I could choose, I just multiply all those. That's the fundamental counting principle. Then there are permutations. So for example, if I'm putting n things in order and I want to know how many different orders can I put those n things in, well, that would be n factorial. Combinations is when we don't care about orders. So this is everything about choosing. So for example, I have 10 options, and how many ways can I distribute 3 successes among those 10 options, something like that. So if these are unfamiliar ideas, it would be worthwhile to go back and watch the videos in the counting module to make sure you're clear on the fundamental counting principle and its relationship to permutations and combinations. That's what we're going to be talking about applying to probability in this video. So for example, here's a question. A committee of 3 will be selected from a group of 8 employees, including Alice and Bob. What is the probability that the chosen committee of 3 includes Alice and not Bob? So this is a classic counting scenario probability question. The whole idea that we have a certain group and we're picking people from this group. Whenever you start doing that, picking people from the group and then applying various restrictions, getting this person, not getting that person, having this person sit next to that person, all that kind of stuff, that is classic counting technique scenario. And so we have to use counting techniques. So let's think about this. So first of all, we can just ask the question, how many groups of 3 can we make from 8 employees? So that would be 8 choose 3. And of course the formula for that would be 8 times 7 times 6 over 3 times 2 times 1. 3 times 2 times 1 is 6, so that cancels. And so there are 56 different groups of 3 that I could possibly choose. So that would be the denominator of the fraction. Usually the denominator is much easier to figure out than the numerator. For the numerator, let's think about this. What would a successful committee look like? A committee that fits the condition we're saying here. Well, we'd have to have Alice on the committee. That's one of the requirements. And then we have these other 2 requirements. Now, of course, the people, there are 8 people altogether. Let's just list these out. So pretend those are the 8 people. Their names conveniently begin with the first 8 letters of the alphabet. So A we've already included. And we don't want to include B. So B is not going to be included. So we could pick 2 people from any of these remaining people. That would be 2 from 6. 2 from 6 could go into these 2 slots. So 6 choose 2. How many different pairs can we pick from 6? That would be 6 times 5 over 2. And of course that equals 15. That's the numerator. And so the probability would be 15 over 56. This is the probability that the chosen committee of 3 includes Alice and not Bob, if we are choosing from this group of 8, assuming that all 8 employees are equally likely to be chosen. So, in summary, we will say, in solving a probability question, sometimes, in fact usually, it's advantageous to use the algebraic probabilities in those rules. Sometimes it's advantageous to use counting techniques. So as the student, when will you know which to use what? That's what we'll talk about in the next video.